Welcome to On Chemistry. Always try to do your best. Now, let us see about 100 concepts in organic chemistry. We are seeing it as episode. This is the episode number 74. If you didn't watch previous episodes, I encourage you to go and see. Here, we solve 5 problems step by step. Stay tuned. Let us see the first question. First question, they given that 4 different alkenes there. All are bicyclic system. First one is 5 member and 5 member bicyclic system with alkene. Second one also same, but it contains the bridged alkene. Third one contains 5 member and 6 member system with alkene in the bridge. Sixth one is bicyclic system with 6 member on both sides and you have alkene there. They are asking most stable among these. So you have to find which one is most stable and which one is least stable. So from the question of bicyclic system and its stability, you might realize the question is really about structure versus stability. The answer is C. Let us see how. Here, before we get into that, we have to know that stability dictated by the two factors. One is strain, one is bridge double bond. If the system with more strain, it will be unstable because it won't hold the position. If the bridged bond also there, it forced to be planar, so it will also unstable. So we analyze these facts between these four structure. Let us see the most stable one. The fourth structure is most stable one because of both sides 6 member ring and no bridged double bond. So it's more stable. Let us look at the second one. 5 member and 5 member ring is there with high strain and bridged double bond is there. It's very unstable. Now we have the competition between 1 and 3. The 3 one has double bond on the bridge. It's highly unstable. Even though it has 6 member, the double bond prevents the shape itself. So 1 is more stable than 3. So if you look at the stability, 2 will come least, then third, then first and fourth will be the most stable one. So the answer is clearly C there. Here the concepts you have to learn here is the double bond effect is higher than the ring strain because it forces the structure to be planar, very highly unstable. Then let us look at the next question. The question is about most acidic species among the protonated amine. The first one is reduced pyrrole with hydrogen protonated and B is pyrrole with protonated and C is pyridine is protonated, D is substituted pyridine. 4 different pyridines basically protonated with acid. So you have to find which one is most acidic among these. From the question of 4 different amine and its acidity, you might realize the question is really about amine versus conjugated acid. The answer is B. Let us see how. Before we get into the fact, we have to know weak base gives strong conjugated acid. So if you analyze the all 4 one, the second one, the B one is more acidic. The reason is on aromaticity. The pyrrole is aromatic because it involves the lone pair of electron and nitrogen to the system. Once you protonate, the system becomes anti-aromatic because it go from 6 pi electron to 4 pi electron. So clearly it's a Huckel rule anti-aromatic system. Aromaticity stabilizes the system, anti-aromaticity destabilizes the system. So it's the weak base definitely. So conjugated acid should be extremely stronger there. That is a reversible reaction. So it will be very acidic. So the answer is clearly B that pyrrole is more acidic. Here the concepts you have to learn here is so the system always go from unstable system to stable system. Then let us look at the next question. The question is really about configuration of the compound. Here they given the alkene attached with the cyclobutane ring kind of spire end system because it's a restricted structure. Basically they differ in the position of methyl and ethyl and hydrogen. They are also differ in the stereochemistry. So 4 different possibilities they given. You have to find which one is hard. So from the question of alkene system, all different configuration, you might realize the question is really about 3D structure and its configuration. The answer is A. Let us see how. Here it will be interesting once you know the fact that you have to do different things for R and S configuration. Normally the viewing side is important. While drawing the viewing side, you have to write with the bold line there. So bold line represents you are reading from that angle that has high priority. That meaning front side has high priority. Then we will write, if you see from the viewing side, hydrogen is left hand side, CH3 is right hand side, and ethyl is above, hydrogen is below. So again I am saying the thicker line is on front side, thinner line is on back side. So front line has higher priority. So if you do that, 1, 2, 3, 4 will come. It is the R configuration. Here you should know the fact that low priority group doesn't matter whether it is front side or back side or vertical or horizontal. Here the concepts you have to learn here is, in 3D system you have to always focus from viewing side. From that you derive the configuration. Then let us look at the next question. They are asking the compound which is not oxidized by potassium permanganate. They given the 4 different substituted pyridine there. First one is with isopropyl group, second one is with multiple conjugation, third one is with ethyl alcohol, fourth one is isopropyl alcohol. So multiple conjugation with pyridine. So you have to find which is will not be reacting with permanganate. So from the question of oxidation and 4 different structures, you have to realize the question is really about structure versus reactivity. The answer is D. Let us see how. Here the answer will be simple if you know the basic fact that benzylic hydrogen required for oxidation. Like aldol condensation required alpha hydrogen, here it contains benzylic hydrogen. The first one contains one benzylic hydrogen, I highlighted red. Second one also contains one benzylic hydrogen. Third one also contains benzylic hydrogen. Fourth one no benzylic hydrogen, so it won't undergo. That is our answer. The answer will be very clear once you know the mechanism. Potassium permanganate, if you react, it should have benzylic hydrogen. That hydrogen form radical with permanganate. Then it will convert it into oxidation process. So definitely it required the benzylic hydrogen. So the answer is clearly T there. Here the concepts you have to learn here is oxidation of aromatic system required benzylic hydrogen. Then let us look at the next question. The starting method is chiral compound with multiple substitution with primary alcohol, with secondary alcohol and aldehyde. You are reacting with H and the product will be diastereomer X plus Y. The question is about you have to find the absolute configuration of X and Y. So they given the all possibilities of those chiral center 2s, 2r, 3s, 3r. Basically you are varying between R and S among these. So from the question of creating new chiral center and its configuration, you might realize the question is really about reaction center versus configuration. The answer is A. Let us see how. Here what really happens is addition reaction. So we redraw nicely for a reaction. You have to redraw aldehyde. Once the aldehyde, the Cn minus can attack from above and below. So you have two possibilities. Definitely it will end up with diastereomer because you are creating the new chiral center and variation in that one. So the third carbon doesn't change in the configuration. So third carbon remaining are there. The first carbon only varies R to S. Here you have to do the priority by CIP rule and hydrogen is horizontal. Hydrogen is horizontal means you have to follow reverse configuration. So R and S mean it will become S and R. S and S mean it will become R and R. So the configuration will be 2S, 3R. 2R, 3R. So the answer is clearly A there. Here the concepts you have to learn here is whenever you create a new chiral center with already chiral center, you might end up with diastereomer. That's all from this episode. I hope it was easy. Thanks for watching. If you have any suggestion, comment below. Stay tuned for next episode.